Good morning.
Hello, good morning.
Good morning.
Okay, so we can start our last lesson. Today is the last lesson of the first part of this subject, and then next week, in particular, next Monday on 3 p.m. There will be the first lesson of my colleague, Professor Marco Marconi, about the second part of the subject. We have to see first of all today the last part, the last step of about the life cycle assessment. In the last lesson, I think that you, my colleague Lorena Foschi, have seen you have explained the CIMAPRO software, also by explaining some examples about LCA case studies. So you have seen the 4 steps of LCA in the CIMAPRO software. You have seen also how you can calculate the environmental impacts of a product or of a process, and after the calculation of the environmental impacts, it's also important to analyze these results. It's important to analyze the significance of these, the significance of the environmental results after the application of a life cycle impact assessment method. So the analysis and the interpretation of the environmental results are the focus of the last step of LCA. The last step is the interpretation step. At this step, the main issues, the main points about this step of LCA, first of all, is the identification of the most significant environmental impacts of our product to be analyzed. Also, we have to, in this step, we have also to evaluate the consistency, of the obtained results. We have to also analyze the uncertainty of the associated to the results obtained after the application of life cycle impact assessment method. So here in these slides, you can see the different the different main points in the interpretation step, but we focus only on 2 points. The first point is the analysis of the most significant environmental burdens. In this case, this step is very important in an LCA study because in this step we have to evaluate which processes or in general which phases of the life cycle of the product are characterized by the most significant contribution to the overall environmental burden. In fact, one of the aim of the LCA analysis applied to a product is not it's not only to analyze the absolute environmental burdens, for example, in terms of kilograms of CO2 equivalent or in terms of other environmental indicators. But another important aim of the LCA study is to evaluate which processes, which unit processes in the life cycle contribute mostly to the total environmental impact in order to define some modifications to the process, some improvements to the process in order to decrease the environmental impact. So this is the first point in the interpretation step of the LCA. In the second important point when we arrive to this step of the LCA is to carry out 2 other important analysis: the uncertainty analysis and the sensitivity analysis. Here in this slide, you can see other 2 different kind of analysis of the results: contribution analysis and gravity analysis. Contribution analysis is another kind of term to define the identification of the significant environmental issues. It's the same kind of analysis. Instead, important is to focus on uncertainty and sensitivity analysis. These 2 kind of analysis are very important when we arrive to this step. First of all, the uncertainty analysis. Now, obviously, we don't see exactly the uncertainty, how it's possible to apply the uncertainty analysis to an LCA study, but we can see the main steps in this kind of analysis. First of all, we have seen when we have spoken about the previous steps of the LCA, we have seen that typically the LCA analysis is characterized by different uncertainties. For example, the main uncertainty of an LCA study is due to the quality of the inventory data used for the environmental evaluation. We have said that we have the possibility to use two different class of data, in particular primary and secondary data. Primary data obtained from direct measurements, instead secondary data from database. So it's obvious that these kind of data, each data is characterized by a specific uncertainty, and so the final results are affected by a certain uncertainty. This is one type of uncertainty in our results, but this uncertainty is not the only uncertainty associated to an LCA study. In fact, we can have other kind of uncertainty in an LCA study. For example, another kind of uncertainty is due to the hypothesis, to the choices of the in the scope definition, in the scope and goal definition step of the LCA. For example, another kind of uncertainty could be due to the to how we want to model the multifunctional processes. If we use the allocation approach, the system expansion approach, in this case, this kind of uncertainty, we can define this kind of uncertainty as a model uncertainty. Instead, the typical uncertainty due to the quality of data used for the LCA is called as data uncertainty. Okay. Between the model uncertainties, we can find also another type of uncertainty. For example, the uncertainty due to the life cycle impact assessment method used to calculate the environmental indicators. We have seen in the previous lesson that we have also, you have seen, I think, in CIMAPRO, you have the possibility to choose to select different life cycle impact assessment methods to calculate the environmental indicators. And so also this choice obviously affects the results, the environmental results of our study, because if we change the impact assessment method, we have different results, different final results. So typically in an LCA study, we have two different class of uncertainties, data uncertainty and model uncertainty. But in general, the most important uncertainty when we evaluate, when we want to communicate the quality of the environmental results obtained from our study, the main class of uncertainty is the data uncertainty. Okay, because about the model uncertainty, we have defined in the goal and scope definition the hypothesis of the study, so and the choices for carry out the study. So typically data uncertainty is the most important one. In the following slide, you have a brief description about how we can calculate the data uncertainty associated to our environmental indicators. So it's not important, obviously, in this course, it's not important to understand in detail the meaning of this kind of analysis, but we can only define, we can only highlight some points in this kind of uncertainty analysis. Okay, first of all, we can say that first of all, we can define the uncertainty. Uncertainty, as you can see, you can read in the slide, is the probability or confidence for a certain event to occur. This is the general definition of uncertainty. Each data in the inventory used for the construction of the inventory of our LCA is characterized by a specific probability distribution. I don't know if you have experience if you with these concepts, but we can say that typically if we have a parameter, if we have an input data or an output data in our inventory data, each input data or output data, for example, a consumption of a material, the consumption of energy, the specific emission into air, into water, or into soil, each data is characterized by a certain uncertainty and is characterized by a certain probability distribution. The probability distribution typically has this shape, of probability distribution associated to a value, to an input or output data. This kind of shape is the Gaussian curve. In particular, in this kind of probability distribution, the mean value of in this graph, the mean value is the most probable value. Instead, then for the same data, you can have for the same value, you can have different data. For example, if you repeat the measurement of the same parameter, I don't know, if you repeat sometimes the measurement of the electricity consumption during the for certain machinery, for a certain equipment, do you you have different values of electricity consumption, even if the duration of the production cycle is the same, if even if the process is the same, and so on. So typically for each data, you could define a probability distribution, and so typically in the software, in the CIMAPRO software, you use always the the most probable value, no? This one in this case, the mean value in this case, in this kind of curve. But you have to know that you have the possibility that for this parameter you can have different data. So if you want to characterize this probability distribution, it's important to define another parameter. This parameter is called as a standard deviation of the probability distribution. In this case, if your parameter is characterized by a normal distribution, Gaussian distribution, as in this figure, in this case, the meaning of standard deviation is very important, because you have the possibility to define a range of values between mu is the mean value. Okay, mu is the mean value, is the most probable value for the parameter. You have the possibility to define a range between the average value minus 2 times of standard deviation, and the average value plus 2 times of standard deviation. So in this range of values, you have, as you can see in the slide, you have the probability that at 95% your parameter assumed a value inside this range. Okay, so you have this important information from the definition of the standard deviation. So if the quality of your data is very good, the standard deviation will be very low, because this range will be not large, but will be very strict. So if on the other hand, if the standard deviation will be high, obviously the quality of your data for your parameter will be lower. So in LCA, but in general, each data could be characterized by different probability distribution. Previously, we have seen the normal distribution. Normal distribution is the most typical probability distribution for a parameter. In order to define this curve, it's important to define, as we have said previously, it's important to define the average value and the standard deviation. With these two parameters, we have the possibility to define completely the normal curve. But in the LCA analysis, data don't follow this kind of probability distribution, but data typically follow the last one, the log normal distribution. Log normal distribution is quite similar to the normal distribution, but the best guess value is not in the center of the curve, but it's is a shift on the left, as you can see in this curve. In particular, in this case, if we want to define for each parameter the curve, the log normal curve associated to each parameter, it's important to define also in this case the best guess value and the standard deviation as in the normal distribution. But as we can read in the slide, a typical property of a log normal distribution is that the square of the geometric standard deviation covers the 95% confidence interval. So a square geometric standard deviation, for example, of 1.2 means about 95% of all measured values are between the mean value times 1.2 and the mean value divided by 1.2. If the square of the geometric standard deviation is equal to 1, there is no variation. All measured values are the same. In this case, with this kind of log normal distribution, this range between you have the probability of 95% to find your value for your parameter is defined in a different way. In this case, the mean value plus or minus 2 times standard deviation. In this case, the range is defined between mean value times 1 times standard deviation and mean value divided by standard deviation. Times square standard deviation or divided by square standard deviation. Okay, this is the important difference. So from this consideration, I don't know if in the last lesson my colleague have seen you the cells in the unit process in the CIMAPRO, where you have to define the information, the data for uncertainty analysis, but in each data, for each data of a process in CIMAPRO software, you have the possibility to define, first of all, the type of probability distribution, and in this case, we have said that for each data, we have to define the log normal distribution. And then it's important to define the best guess value and also the standard, the square standard deviation value for each data. As regards the best guess value, it's quite easy to know the best guess value for each data, because the best guess value, for example, if we obtain a value from a database, from a report, from a scientific paper, in these reports, we can find only one data that is the best guess value. We don't have a range of different kind of values for the same parameter. So the best guess value, it's easy to define. Instead, it's very difficult. We can have very difficulties to to define the square standard deviation for each data. Because if we want to calculate exactly the square standard deviation associated to each data, in theory, we have to know different list of different data for a list of different values for the same parameter obtained from, for example, from different measurements and so on. So the calculation of this parameter is not possible in all cases. It's not possible to calculate the real standard deviation, the real square standard deviation for our parameter. So in this way, we have the possibility to apply the same approach used by the EcoInvent. This approach is called as a pedigree matrix approach, and in particular, with this approach was used by the authors of EcoInvent database in order to calculate the square standard deviation for each parameter in the unit processes of this database. If you open a process in the CIMAPRO software from EcoInvent database, you could see that each parameter, each input or output data is characterized by the log normal distribution and by a value of square standard deviation. So the idea is to copy this approach to calculate the square standard deviation also for for example, for our data that we use in our life cycle. This approach is called as pedigree matrix. This approach is based on this assumption. The assumption is that each data is characterized by two different types of uncertainty, basic uncertainty and additional uncertainty. Basic uncertainty, as we can read in the slide, the basic uncertainty is due to the intrinsic variability and stochastic error of the parameters. For example, typically this uncertainty is due to the measurement uncertainties, to the temporal variability, to the activity-specific variability, and so on. Instead, the additional uncertainty takes into account a different form of uncertainty. In this case, we refer to the uncertainty due to the use of imperfect data, for example, data resulting from estimates, or extrapolated, for example, from temporally, spatially, or technologically different conditions, and so on. From these definitions, we can say that, for example, Sorry, but the electricity went out due to a rainstorm. So I hope that the problems are solved. Okay, so we can restart. Okay, so we have seen the two different types of uncertainties: basic uncertainty and additional uncertainty. About the basic uncertainty, we have said that this basic uncertainty is typical for primary data. Instead, additional uncertainty, we can have this kind of uncertainty for secondary data. So we can say better that for secondary data, we have both types of uncertainties: basic uncertainty and additional uncertainty. Instead, for primary data, we have only the first one. We have only the basic uncertainty, because additional uncertainty, if the data is measured, obviously it is not obtained, it is not drawn from a database, from an estimate, and so we cannot have this kind of uncertainty for primary data. So in this pedigree matrix approach, after this definition of data uncertainties, we can calculate the square standard deviation. I remember you that in order to define the log normal probability distribution for a parameter, we have to define the best guess value and the standard deviation, in particular the square standard deviation for the log normal distribution. For the calculation of the square standard deviation, we have to apply this equation. It's very easy, this equation. So the square standard deviation is simply calculated as the sum of the different square standard deviation for basic and additional uncertainties. We can explain better. In fact, in this equation, we can see that the square standard deviation for a parameter is obtained as the sum of 6 different square standard deviations: sigma 1, sigma 2, sigma 3, sigma 4, sigma 5, and sigma 6. About sigma 1 is the square. Sigma 1 is the standard deviation of about the basic uncertainty. Okay, so if the data is a primary data, as you can see in the slide, this value is equal to 1. The meaning is that this data is not affected by uncertainty. Instead, the other 5 square standard deviations are associated to the additional uncertainty. In fact, the additional uncertainty can be in the additional uncertainty, we can define 5 different uncertainties about the reliability, completeness, temporal correlation, geographical correlation, and technology correlation of the data. So the next question is how we can calculate these 6 values, these 6 square standard deviations, because if we have only one data for a parameter, it's very difficult to calculate these 6 square standard deviations. In order to calculate these values, by applying the pedigree matrix approach, we have the possibility to use 2 different tables. The first table is this one. In this table, we can obtain the square standard deviation for basic uncertainty. So in this table, you have different kind of data, and so you have to choose the square standard deviation typical for your parameter. So, for example, if you have an electricity consumption as the input data for your unit process, so for this value, for this parameter, for this electricity consumption, you have to consider the first line, demand of electricity. In the first line, you have all data refer to thermal energy, electricity, demand of thermal energy, electricity, semi-finished products, working material, waste treatment services. So in this example, you have to refer to this first line. Then you have 3 different columns. The first column is for combustion emissions. The second column, P, is for process emissions. The third column is referred to agricultural emissions. So if you want to define the square standard deviation for your data, you have to know not only the type of data, but you have to know also the context of your data. So, for example, if you have an electricity consumption in an industrial process, so in this case, you have to consider the column P, process emission. If you have, in the case, if this electricity consumption is related to, I don't know, an agricultural process, so in this case, you have to consider the column A. In this case, you don't have any problems because the square standard deviation for this first line is the same for all 3 columns, 1.05. But you can have other kind of data for which you don't have the same data. For example, in this case or in this case, and so on. So in this way, you have the possibility to define with this approach, you have the possibility to calculate, to define the exact value of square standard deviation for the basic uncertainty. In the same way, we can define the square standard deviation for the other 5 additional uncertainties. I don't think if this table, you can read this table, but about, I don't know, one of the criteria, for example, the geographical correlation. If we want to define the square standard deviation for the geographical correlation, we have to define the quality of our data. We have to define the quality of our data by using a score from 1 to 5. So the score 1 is for data with a optimal correlation, with an optimal geographical correlation. So, for example, if we find data from a database, and if this data was obtained from the same area under study, in this case, the geographical correlation of this data is optimal, and so the score is equal to 1, and so the square standard deviation is equal to 1. Instead, for example, if the, I don't know, in this case, if the data was obtained in the database from an area with slightly similar production conditions, in this case, the quality is not very good, and in this case, the square standard deviation is equal to 1.05. So in the same way, we can calculate the square standard deviations for the other classes of additional uncertainties. The idea is to define a score for each quality criteria. You have 5 quality criteria for your data in terms of reliability, completeness, geographical correlation, temporal correlation, technological correlation. Okay, according to these 5 criteria, you have the possibility to define the possibility to define a score between 1 to 5, and so you have the possibility to determine the square standard deviation for your parameter. In this way, you can calculate the overall square standard deviation for your data, for your parameter, by summing the square standard deviations for basic and additional uncertainties. So this work is not very easy, but it's important if you want to demonstrate the quality of your results. So then, when we have calculated and when we have defined the square standard deviations for each data of our inventory, the last step is the calculation of the uncertainty results. So the calculation of the total uncertainty associated to our study is carried out by using the software. And software, the CIMAPRO software uses the Monte Carlo method, the Monte Carlo simulation approach, to calculate the uncertainty of our study. Monte Carlo method is a very used method for the calculation of uncertainty, not only in the LCA field, but also in other context. In particular, the main feature, the main point of the Monte Carlo approach is very simply because the idea is to follow these 3 steps. In the step 1, software generates samples of random values for all input variables. So for each data of your inventory, software defines randomly defines different values between the range between the range from mean value times square standard deviation and mean value divided square standard deviation. In this range, software define a random value for each parameter, and then calculate the environmental results by using these random values. And at last, the software repeats this approach, this procedure, for several times. In particular, typically 1,000 times. Okay, so for 1,000 times, software repeats this generation of random values and the calculation of the final environmental results. In this way, you have 1,000 different environmental indicators for your LCA. And so with these 1,000 different environmental results, you have the possibility to calculate the statistical parameters associated to this class of results. And in fact, for example, you have the possibility to calculate from the software for each impact category, as in this figure. You have the possibility to calculate for each impact category the typical range, with this red bar, the typical range of variation of the environmental indicator for this impact category. In particular, each range expresses the 95% confidence interval. This means that 95% of the results lay within this range. So this is an important point. This is an important result because you can communicate to the final user of your study the quality of the results. Okay, if the bar is large, as in this case, the meaning is that your result for this impact category will not very good. On the other hand, for example, for other impact categories with strict range, you can consider that this result has an optimal quality. Yeah, but then from the software you have the possibility to calculate for each impact category also other statistical parameters, the mean value, the median value, the standard error of mean, but it's not important. It's important to define this range for each impact category. Okay, this is the most significant result from the uncertainty analysis. And the uncertainty analysis can carried out, for example, in the CIMAPRO software. The only point to carry out the uncertainty analysis is the calculation of the previous square standard deviation by using the pedigree matrix approach. The application of this approach requires a long time because it's not very easy, but it's not very complex, because you have to only to select the standard deviation from these tables for each data. But if the number of your data in your inventory is very large, in this case, the time necessary to complete the calculation of the square standard deviations will be very, very long. Okay, so this is not very important. Instead, the other important analysis in the interpretation step of the LCA results, the other important analysis is the sensitivity analysis of the results. In this case, the sensitivity analysis of the results is important to verify some hypotheses of your study. In fact, sensitivity analysis is a kind of analysis during which you change one of your assumption, one of your hypotheses, and then you have to recalculate the environmental scores, the environmental indicators, in order to compare, if you compare both results with different assumptions, you have an idea of the exact influence of this assumption on the results. For example, if you want to change the allocation procedure, the allocation method, this could be an interesting point to analyze in order to verify if the allocation approach can change significantly the final results. If you obtain that the final results are not affected by this choice, this result is important because you communicate to the final user that this choice, this assumption is not very important, does not influence does not influence the results. So in the same way, you can apply with the sensitivity analysis to other kind of assumptions during the life cycle. Okay, so typically in each report, in each LCA report, in each scientific paper about LCA, you can find sensitivity analysis and uncertainty analysis. Without these two kind of analysis, the study is not very credible. It's not very could be more uncertainty. Okay. So at the end, after the the analysis of the different steps of LCA, we have to see the environmental labels actually in the market for products. And in particular, we'll see that one of these environmental labels could be obtained after carrying out an LCA study. First of all, we can say that actually for the products, we have the possibility to obtain 3 kinds of environmental labels. These environmental labels are used by the companies to communicate to the consumers different information about the environmental performance of the product, but with different meanings and with the different aims. In particular, in this slide, we can see that we have 3 different environmental labels actually, type 1, type 2, and type 3. Each type of environmental label is defined in a specific technical standard. For type 1, we have ISO standard 14024. For type 2, the technical standard is 14021. And for the third type, the technical standard is 14025. Only the last one, only the type 3 environmental label is associated to an LCA study. The first two labels don't require an LCA study. So for us, the type 3 is the most important environmental label, obviously. Here you can see a brief summary of the main features of the 3 labels. First of all, the type 1 label is obtained after a validation by a third-party entity. Instead, the type 2 label is only a self-declaration. So typically, this environmental label does not require a validation by a third-party entity. And at last, obviously, the type 3 requires also in this case the validation and the verification by a third-party entity. Only, as we have said previously, only the third type requires a mandatory LCA study. And for this reason, the third type label is the most complete and complex label between these 3 different options. But also type 1 is an interesting environmental label for different reasons. In this slide, you have an idea of the aim of this kind of label. First of all, type 1 labels are of, as we have said previously, are of third-party labels, verification required by a public or private body. These labels are assigned to products that meet certain environmental and performance criteria. These criteria are predetermined for each product category and are in the public domain. These criteria are defined considering the environmental aspects throughout the product life cycle through an open consultation process with the interested parties. So in this case, the product can obtain a type 1 environmental label only if this product satisfies predetermined environmental criteria. So for each product category, we can have different environmental criteria. For example, I don't know, for energy-related products, a typical environmental criteria to obtain this kind of label is about the energy consumption during the use of the product. So for each product category, for each product category, for example, the electricity, the maximum amount of electricity consumption is defined during the use of the product. This could be an example of environmental criteria. And these environmental criteria are defined after the application of the life cycle analysis to an average product for that product category. So from this LCA analysis, the European Commission, for example, defines the threshold, the different thresholds for each environmental criteria, but the single company does not carry out the LCA study, but company should only demonstrate that its product reaches the threshold of for each environmental criteria. So the idea is that in this case, if a product obtains a type 1 environmental label, this product can be considered as an excellent product from an environmental point of view, because the thresholds for each environmental criteria defines the limit between defines the limits between the excellent product and the average market product for that product category. So this is an important point. Worldwide, in the world, we have different kind of type 1 environmental label. In Europe, the most famous and the most widespread type 1 environmental label is the first one in this slide, Ecolabel. The European Ecolabel is the most known type 1 label in Europe. But you have, in the slide, you can see that in the market, some products could have other kind of marks, other kind of labels. For example, in Australia, you have the name of type 1 label is environmental choice. In Japan, eco-mark, and so on. As regards the European type 1 label, Ecolabel, this environmental label was established by the European Union in 1992, This label is a voluntary label. Also, the other two labels are other examples of voluntary labels. We don't have environmental labels that are mandatory. Okay, all labels are voluntary. Yeah, the system, the eco-label system is managed directly by the European Commission and the member states. Also, it can be awarded to non-European products placed on the European market. Actually, we have 34 different product category groups for which we can find the thresholds in terms of different environmental criteria. So, for example, you have electronic displays, I don't know, textiles, footwear, paints and varnishes, graphic paper, tissue paper. So you have 24 different product groups, and for these groups, it's possible to obtain a type 1 environmental label. This is the website where you can find all information about this type 1 environmental label. These statistics are not very recent because these statistics are referred to 2021, but actually the data are not very different to these reported in this slide. In particular, actually, the environmental type 1 labels are mostly for paints, tissue paper, hard coverings, and textiles. And the leading countries are Spain, Italy, France, and Germany. So these data are similar to data referred to 2024. But here you can have more recent data for more recent statistics. Okay. As regards the type 2 label, type 2 labels are self-declaration labels. In this case, these labels are not mandatory, and in particular, they refer only to one environmental criterion. Okay, this is another important difference than the eco-label. The main two differences are that type 2 are self-declaration labels, and they refer only to one criterion. So as we can see in the slide, this standard provides guidance on the use of certain environmental terms, symbols, or charts that describe environmental product characteristics. Obviously, this label is not very useful because typically this self-declaration is not verified by a third-party entity, so the credibility of this label is not very high than type 1 and type 3. Typically, in these type 2 environmental labels, a company declares that its product, for example, is compostable or is biodegradable or is recyclable or is characterized by reduced energy consumption during the use, reduced water consumption, but these declarations are self-declarations. So in the ISO standard 14021, you can find different criteria for these self-declarations. For example, the company cannot use general terms as, for example, friendly, green, environmental safe, earth friendly, because these kind of terms can generate the so-called greenwashing, okay? Because the term green does not has not a real significance, okay? Significance. So in the technical standard, you can find different rules about the use of different terms for these self-declarations. So this kind of environmental label is not very useful, but the main advantage of this label is that this label is more economical because they require no third-party certification or validation. But on the other hand, a lack of certification and validation reduces credibility of this information to the consumer. So here you can see, for example, the only two declarations that are defined in the technical standard. In particular, in the technical standard, you can find how you can declare and how you can obtain this kind of label about the recyclable or recycled content of the material. I think that you have seen in some packaging of products this symbol. This is the Mobius cycle symbol. And the meaning of this symbol is that the packaging of the product is recyclable. But this information is a self-declaration information, not validated by a third party. Okay, here you can see other kind of type 2 claims from different associations. So in different part of Europe or by different companies. So in the market, you have the possibility to find a very long list of different type 2 labels. But the main problem is to understand the real meaning of these labels. It's not easy for the consumer to understand, to know the meaning of these labels. So I think that one of the main reason of the greenwashing problem actually is due to these kind of claims, of these kind of labels. So this is obviously my idea. So now we can stop here for a break, and then we'll finish with the type 3 label. 15 minutes, about 15 minutes, and then we can restart. Okay, so we have seen the first two types of environmental label. Now we have to see the main features about the third kind of environmental label, the type 3. Type 3 label is also called as environmental product declaration. In this slide, you can see some information about this type of label. This label is a set of quantified information related to the product life cycle. So is based on an LCA study of the product. The third point is an important point because this kind of label cannot be used to evaluate, for example, if the product is environmental better, or if the product is so we cannot use this kind of label to evaluate if for example, if the product satisfy certain environmental laws. A product certified by characterized by an environmental product declaration, this is not this doesn't mean that the product is a good environmental is good from an environmental point of view. If we want to define if the product is better than is an excellent product than the average products in the market for that product category, we have to consider the type 1 label. In this case, we evaluate the overall environmental impact during the life cycle of the product. So we have an idea about the environmental burdens during the life cycle, but we don't know if the product is a good product or not a good product. So from the environmental point of view, this is an important point. This label is also verified and validated by a third-party entity, and so in the market we have the possibility to find different marks, different kind of environmental type 3 labels. The most known environmental type 3 label in Europe is the first one, the International EPD Consortium. In Italy, from I don't remember, I think from 2020, 2019, I don't remember. In Italy, we have also the EPD Italy. EPD Italy is the environmental product declaration for the Italian companies. But an Italian company can also certify its product by other different by using other different labels. So we can find actually in Italy some companies that have certified their products with EPD Italy or with the EPD by the International EPD Consortium. The reason is that sorry, I don't remember the the reason is that sorry, the reason is that each logo, each type of environmental label is managed by a different entity. Okay, so each entity, each society, in this case, in the EPD, in the European EPD, the certification scheme is managed by a Swedish society. Instead, the EPD Italy is managed, this label is managed by an Italian society. So each environmental label is managed by a different company, different society, different organization. Obviously, each organization should follow the criteria of the technical standard ISO 14025. So each company that it wants to obtain the type 3 label of EPD Italy should follow the rules defined by the organization that manages this kind of certification. This is the same approach. This is the approach for also for the other type 3 environmental label. In this slide you can see how the information and the data from an environmental product declaration can be used. For example, this information can be used for internal environmental management, for business to business, for business to consumer. This is a voluntary environmental label, and typically the main aim to obtain this label is for business to consumer, in order to inform the consumers about the environmental performance of the products company. So typically, this is the main aim to obtain this kind of certification. Also, here you can see some of different assumptions for the life cycle useful to obtain the type 3 label. In particular, if a company decides to carry out an LCA study for obtaining the environmental product declaration, company should consider that the life cycle study should carry out should be carried out by considering the different hypotheses reported in a particular document. For each kind of product category, the organization that manages the certification scheme publishes a document, and the name of this document is a product category rule, where organization defines, in accordance with the technical standard ISO 14025, defines specific guidelines for carrying out the LCA study for these kind of product, and in particular in these PCRs, in these product category rules. For example, you can find some information about the functional unit, about the system boundaries. So the LCA practitioner in this case should follow exactly the guidelines reported in the product category rules. So should consider the same functional unit, the same system boundaries. So all hypotheses in the goal and scope definition in this case are defined in the product category rules. In this way, the LCA studies are more comparable each other than the case, the situation in which these LCA studies are carried out only by following the general technical standard ISO 14040. Also in the product category rules, we can find not only the functional unit, not only the system boundaries, so not only the unit processes that we have to consider in our LCA, but for example, we can find the definition of the impact assessment method to use to calculate the environmental results. Also, we can find the rules, the specific rules to collect inventory data. We have specific rules about primary and secondary data. We can find guidelines about which processes should be modeled with primary data and which processes should be modeled instead with secondary data. So in this way, the rules are well specified for each product category. In this way, the environmental results of the products belong to the same product category are more comparable each other, okay, in this case. Typically, in these product category rules, the life cycle of a product is divided into three main steps: upstream processes, core processes, and downstream processes. In this slide, you can see which processes are included in the upstream, core, and downstream. Typically, upstream processes include raw material acquisition, refinement, production of intermediate components. Core processes instead are related to the manufacturing processes, and at last, the downstream processes include the use phase of the product and the end of life stage of the product. As I have said previously, in these guidelines, we can find also specific requirements about the data quality to construct the inventory. In particular, inventory data are divided into two classes of data: specific data and generic data. Specific data are the primary data. Generic data are the secondary data. So obviously, if we have the possibility, it's better to use for all inventory data specific data. But we have said previously that this scenario is not possible. So in the guidelines, typically, you can find that specific data, so primary data, should be used only for the core processes. Okay, only for the core processes. Guidelines require that you have to use primary data. Instead, for upstream and downstream processes, you can use also secondary data. Also, you can find that secondary data in the type 3 environmental label is divided into two subcategories: selected generic data, typically from databases, for example, from EcoInvent, or proxy data. Proxy data are typically are data from reports, scientific papers, so are data that don't fulfill all of the data quality requirements. So if we have the possibility, it's better to use selected generic data. In fact, typically, if selected generic data are not available, proxy data may be used, but the environmental impacts associated with proxy data shall not exceed 10% of the overall environmental impact of the product system. So in the guidelines, we can find these threshold for the use of proxy data. Also, for example, in the guidelines, you can find other rules. You can find, in particular, specific rules for the allocation of co-products. In this case, in the environmental product declaration scheme, the system expansion approach cannot be applied, but we can apply to model the multifunctional processes only the allocation approach. In particular, we have to use first of all the mass allocation approach, and then if this approach is not applicable, we can use, for example, the economic allocation. So you can find also other guidelines, other rules for the allocation of waste, but now it's not important for us. Instead, I want to see you an example. An example of PCR. One moment, because I have a problem. Okay. I want to share you. I don't know which is the problem. Okay. This. Okay. So here I share you an example of the product category rules for in this case for this kind of product for chair. Okay. This is the product category rules for chairs, for office chairs. This product category rules is drawn from the program operator that manages the environmental product declaration. So in this case, in this document, you can find all information to carry out the LCA study by adopting specific rules. So, for example, I don't know, the most important information are here. Okay, in this section, goal, scope, life cycle inventory, life cycle impact assessment. For example, you can see the functional unit of the product. In this case, you can see that the declared unit should be defined as one unit of product. This product category rules. This document is valid for not only for chairs but in general for furnitures. So in this case, the functional unit is one piece of the product. Also, you have the definition, for example, of the system boundaries. For this kind of product, the system boundaries and in particular the life cycle stages are divided, as we have said previously, in upstream, core, and downstream processes. Here you can see the list of processes in the upstream category. Then you can have the list of core processes, the list of downstream processes. So the LCA practitioner should include in the study all these processes. It's not possible to obtain this label without one of these processes from the LCA. So here you have the flow diagram of the product for this kind of product. You can find the cutoff rules. The cutoff rules, I remember you, that are the rules to exclude some data from the inventory. In this case, the cutoff rule is based on a mass basis. In particular, you have the possibility to exclude all input or out or all input data characterized by a mass lower than 1% of the mass of the product to be analyzed. Here you can see the allocation rules. As we have said previously, typically the mass allocation basis, the mass allocation approach is the approach that you have to use to solve the multifunctional processes. So you can see also the data quality requirements to carry out the study. You can see the definition of specific and generic data. You can have the specific rules for using the generic data, as we have said in the slide. Okay. And also you can see, for example, the recommended databases for generic data. In this case, for example, EcoInvent is recommended for all processes of the life cycle, but for each material you have the possibility to use other kind of database, but EcoInvent is the most important one, so it could be used for modeling all processes. Then here you have you can find which impact categories and which impact assessment you have to use to calculate the environmental indicators for your product. So here you have specific rules for modeling upstream, core, and downstream processes, and also other information. So here, these are the main information that you can find in this kind of document. Also, sorry, I want to share you an example of environmental product declaration by a company. So I share you the screen, this one. Okay, this is an example of environmental product declaration for a chair, an office chair. This is the producer of this product, an Italian company, I think. I don't remember, but I think that is an Italian company. This is the model of the chair, Catifa 46. This document, this environmental product declaration, is a public document, so you have the possibility to download the environmental product declaration of the certified products from this website, environdec.com. This website is the reference website for this certification scheme managed by the Swedish organization, by the Swedish society. Instead, for the EPD Italy, you have another website, obviously, and you can find, in that case, all environmental product declarations for certified by the Italian scheme. In the environmental product, in this document, typically you can find the main hypothesis of the study. You can find the main results of the study, but you cannot find the inventory data used for modeling the life cycle of the product, because the inventory data cannot be shared by the company to the final user. Okay, so you can find the hypothesis, the results, but not the inventory data. In this document, you can find the name of the organization that manages the certification scheme, the Swedish organization, the name of the Swedish organization is this one, EPD International, AB. You can find the reference standard, ISO 14025. The name of the product category rule, in this case, the product category rule is this one. The publication date and the EPD and the deadline of the EPD. In fact, every 3 years you have to update the data in the environmental product declaration, and so each EPD is valid within 3 years from the publication. So in this document, typically you can find first of all a description of the company, a description of the product. This is the product. This is the chair to be analyzed. You have here a sort of bill of materials. Okay. In particular, in this environmental product declaration, company decided to certify 2 products, Catifa 46 with 4 legs base and Catifa 46 with trestle base. So we can find the results for these 2 kind of products. Then you have the different hypothesis of the study, as reported in the product category rules. The functional unit is 1 piece, so 1 seat, with a duration of 15 years. Here you can see the system boundaries of the study, the upstream processes, the core and downstream processes. In this case, for example, no cutoff rules were applied. So you have the other hypothesis, the allocation rules, the definition of the data quality requirements in accordance with the product category rules. In this case, the LCA was performed using the CIMAPRO software. As reported in the PCR, the use of proxy data does not exceed the limit of 10% of the overall impact. Okay, and then you can find the environmental impact indicators. Typically, the results are reported in several tables. In particular, in this table, you can find the environmental results for the different impact categories reported in the product category rules, and the results are reported for the upstream, core, and downstream processes. Each impact category is expressed with a specific unit. So here you can see the environmental indicators. Then typically in the environmental product declaration, it requires to report other information about the environmental profile of the product. For example, the amount of renewable and non-renewable resources consumed during the life cycle of the product, the water use, the production of different kind of wastes. So you typically it's required to report other additional informations about about the environmental performance of the product. Here in this table, you can see the first table. You have the first model of the chair. Here you have the second model of the chair, and so on, with different characteristics. So this is an example. This is an example of product environmental declaration, and at the end you have the name of the third-party entity, the third-party verifier. So all the informations about the LCA studies, the LCA study useful to obtain this certification. At last, sorry, one moment. One moment. Okay. So at last, I want to say you that in the European context, in the last years, in the last 6-7 years, European Commission decided to develop another environmental certification. This environmental certification is called as product environmental footprint. The product PEF, the PEF is a particular method aiming to provide a common and harmonized way of measuring and communicating environmental impacts of products or services at the European level. The criteria and the rules of the PEF are similar to the rules of EPD. In fact, also in this case, if a company wants to obtain this certification, PEF, should carry out an LCA study by following specific rules. These rules are in similar documents called as product environmental footprint category rules, which provides the rules for performing a PEF for different product category. But the main difference is actually this scheme is not very widespread in Europe. Actually, we have in a so-called transition phase. So this scheme is not mandatory for the companies. It's a voluntary scheme. But I want to highlight only the main differences with the EPD system. The main differences are briefly summarized in this table. In particular, the main aim of the PEF scheme is to obtain for the same product category, the main aim is to obtain comparable results from different products in the same belongs to the same product category. Which is the reason? The main reason is that in the EPD scheme, we have said that in the PCRs, in the product category rules, we can find specific guidelines to carry out the study. But we have a main topic, a main critical topic about the secondary data used for modeling the inventory of the life cycle. In fact, in the EPD, the LCA practitioner can use different databases, as we have seen, for example, in the PCR of seats of chairs. Also, in the same database, you can find different processes to model the same process. For example, you can have several different processes to model the production of 1 kilogram of steel by using different technologies. So this is the most critical point when we want to compare the environmental results from two different EPD about two different products, because the differences in terms of environmental results can be due not only to real differences in the process, but only due to the different processes, to the different secondary data used to model the life cycle. And so with the PEF scheme, the European Commission wants to overcome this problem, wants to obtain environmental results more comparable between different products belongs to the same product category. But in order to reach this aim, the main problem is to define a specific data set, specific database for each kind of product category. So in this case, in the PEF scheme, for each product category, we have also a specific data set of secondary data to model the inventory of the life cycle of the product. In this way, the LCA practitioner should carry out the study by following the same rules for different products. This is the main aim of this scheme. But in order to reach this aim, and in particular, in order to make these specific data sets, it's not easy to make these specific data sets. So the creation of these data sets requires a very long time. Okay, this is the main problem. So the other main difference between EPD and PEF scheme is that in the EPD scheme, in the EPD system, we calculate absolute environmental scores, absolute environmental indicators, but it's not possible to define a rank for our environmental, for our product from an environmental point of view. In this case, in the PEF scheme, the idea is to define a sort of ranking about the environmental performance of the products for each product category. For example, we can see this one. For example, the idea is that in the PEFCR, in the product environmental footprint category rules, we can find also the average environmental performance, the environmental performance of an average product for each product category. So we can compare the environmental performance of our product to the results obtained for the average product in the market for that product category. This is the other main difference between a PEF scheme and environmental product declaration. So in this case, with the PEF, in theory, we, at the end of the study, we can know if our product is better than the average market or not. Okay, this is the aim. But also to obtain these results for the average product it's not easy, because the variables are very much. So it's not easy to define an average environmental performance for each kind of product category. So in this way, these are the main reasons for the construction, for the definition of this new new certification scheme, PEF. Okay, and I think that it's all for this part of the course. Okay, we don't have enough time to see in detail the different schemes about PEF or EPD, but we can see only a brief summary of these two main certification schemes based on the life cycle assessment of a product. So we have finished. So next, as I have said previously, next Monday, Professor Marconi will start the second part of this course, of this subject, and so I think that he will finish his part at the end of November, I think. Okay, bye bye, and for all questions, you can write me an email. Okay, bye bye.
Thank you very much. Bye.